A forgiving search box is great until it starts ranking nonsense. This is how to tighten Meilisearch without losing typo tolerance. This is the workflow you'll know how to run when we're done, which ranks documents for a misspelled query by prioritizing exact intent and softly penalizing typos. I'm Professor Pi, teaching search and IR with simple Python. Search that forgives small typos is terrific for user experience, but it can also surface results that match common tokens instead of the true intent. Meilisearch gives us a mix of simple rules to reorder, plus stop words and typo control. That makes it easy to steer relevance without training a model. Success here means a top result that matches the user intent, even when a term is misspelled, while still showing fuzzy matches lower down. At a high level, we want three things. First, treat distinctive tokens as more important than common ones. Second, prefer exact matches when possible. Third, allow typos, but penalize them gently. Small indexes and quick tests are enough to see behavior. You will learn how to seed an index, measure a baseline score, reorder rules, add stop words, and validate with tougher misspellings. We will build a tiny product index, run a misspelled query, inspect scoring, change ranking order, add a stop word, and test a harder typo. The goal is not a production deployment, but a repeatable workflow you can run locally to tune relevance. Now let us try the first experiment. This snippet connects to a local Meilisearch instance, seeds a tiny index, and runs a first typoed search. First, it creates a client pointed at localhost and prepares a short list of product records with minimal titles, so results are easy to read. The call to create index creates a products index with ID as the primary key, and the add documents call writes those records into the index. The helper wait for task ensures ingestion completes before we issue the search. The search runs a query with the misspelling cable and stores the top hit in the variable top. If the top result is a charger or some other non-cable item, that tells us the default ranking favors typo-free token matches over the distinctive intent token. The printed title highlights this initial relevance behavior and gives us a clear baseline to change from. Next, we will capture the numeric ranking signal so we can compare settings. This example inspects Meilisearch's default ranking signal for the same query. It assigns the typoed search text to a variable q so we can reuse it without changing code. When the search call includes show ranking score set to true, Meilisearch returns a numeric entry named ranking score for each hit. The snippet extracts that score for the top result into a variable SC, so you can quantify the strength of the winner under default settings. Treat this score as a comparator across experiments rather than an absolute quality measure. Later, when we adjust rule order or other settings, you should see this number move. The printed score gives a simple baseline for tuning and tells you whether changes make a measurable difference. Now we will change the ranking rule order to favor exactness over typo. This code updates Meilisearch ranking rules so exactness evaluates before typo, which reduces how strongly typos demote intent-carrying terms. It builds a reordered list of rules, keeping the defaults but moving exactness earlier in the list and placing the typo rule later. The update settings call applies this new ranking rules configuration to the index, and wait for task pauses until Meilisearch confirms the change. The code then repeats the same typoed query to let you compare before and after behavior with identical input. Prioritizing exactness earlier often surfaces items that match the distinctive token even if it is slightly misspelled. If you move the typo rule even further down, fuzzy matches gain more tolerance at the cost of some precision. The printed title after this change shows whether the top result now aligns more closely with user intent. Next, we will reduce the influence of a frequent brand token that can drown out intent words. This snippet adds a stop word in Meilisearch, so common tokens stop overpowering intent words. It constructs an update settings call that sets stop words to include the term iPhone, so that Meilisearch ignores that token during ranking. The client wait for task call ensures the stop words list becomes active before we test again. Running the same typoed query shows how results shift when a high-frequency brand token no longer contributes to score. This helps rarer, intent-heavy tokens like cable rise in rank. Adding more stop words widens the effect, while removing them narrows it. Use stop words carefully so you do not accidentally hide important brand or domain terms. The printed title confirms whether the top hit now aligns better with the specific intent. Now we will stress the system with a tougher query that has multiple errors. This example validates the tuned Meilisearch behavior on a tougher query with 2 typos. The snippet assigns a more severely misspelled string to the variable q, so we can see how recall behaves under noise. The index search call requests only the top 3 hits to keep the output focused, and the code collects the first 2 returned titles into an order list for quick inspection. With exactness evaluated earlier, and stop words reducing misleading matches, items that match the distinctive intent token should surface first, while still allowing fuzzy matches below. If results become too permissive and irrelevant items float up, consider moving the typo rule later or tightening typo tolerance. The printed ordering shows a more stable, intent-first ranking under noisy input. In a real project, you would map these steps to your product dataset, run the same tuning across sample queries, and pick a rule order and stop words that generalize. The workflow is quick and repeatable for incremental improvements. Recap. It's a small Meilisearch tuning workflow that seeds an index, measures a baseline, reorders ranking rules, and softens common token influence. Use this when typo-tolerant search returns off-intent results, and you need predictable top hits. Caveat: aggressive stop words or moving exactness too far up can hide valid brand matches or reduce recall for unusual queries. Next step: tune the typo tolerance threshold and the position of the typo rule to find the sweet spot between recall and precision on your real query set. If practical, hands-on IR helps you more than theory. Subscribe and watch the IR videos.